Hello student, I am your Rasayan Guru Dr. Sharma. We have already studied the different two rearrangement. First one is the Hoffman and second one is the Wolf rearrangement. Now in today's video, I am going to discuss Fry's rearrangement. And in Fry's rearrangement, we'll discuss its introduction, principle, mechanism, applications and limitations. So let's start our new rearrangement, but I don't think so this is the right place to discuss our rearrangement. So let's move to our class. Welcome students to my class. Now in this lecture, we are going to study new rearrangement, that is Fry's rearrangement. First question is that, what is the Fry's rearrangement? Fry's rearrangement is an organic rearrangement in which aryl ester is transformed into a mixture of ortho and para isomer of hydroxyaryl ketone. These reactions generally occur in Lewis acid catalyst. Generally AlCl3 is used as a catalyst in aqueous acidic medium. Now next part of the rearrangement is principle. This is one of the important part. Now in its principle, when a phenolic ester is heated in presence of the Lewis acid AlCl3, often in absence of the solvent, and the product is subsequently hydrolyzed, then a mixture of ortho and para hydroxyketone is obtained. This systematical reaction is generally known as Fry's rearrangement. Now next part of the rearrangement is the most important part, that is the reaction. Now in this reaction, when phenyl ester undergoes rearrangement in presence of the anhydrous AlCl3 in aqueous medium of acid, then it is converted into a mixture of ortho hydroxyaryl ketone and para hydroxyaryl ketone. These two are isomers of each other, and these two isomers can easily be isolated by different industrial separation technique. Now next part of the reagent is the mechanism. This is the heart of the rearrangement. Now mechanism is just given on your screen. Phenyl ester when reacts with the AlCl3, then oxygen of the phenyl ester is bearing two lone pair of electrons. So these oxygen will donate one lone pair of electron to aluminium, because aluminium is Lewis acid and it is converted into an intermediate. In this intermediate, oxygen donates its lone pair of electron, that's why it is converted into plus charge, while aluminium gains one lone pair of electron, that's why the charge on the aluminium is negative. Now these intermediates is converted into different two components. First one is the acyl ion and second one is the phenoxyaluminium trichloride. The question is how it can happen. So first of all, the bond between carbon and oxygen will be broken. So due to the less electronegativity of carbon of acyl ion will be converted into positive charge and oxygen will take its lone pair of electron back from acyl ion. That's why phenoxyaluminium trichloride and acyl ion obtained. Now during the ortho attack of acyl ion, an intermediate is obtained. Same question, how does it form? So in this case, pi electron which is present between carbon number 1 and 2 will be shifting on carbon number 2. So carbon number 2 will be converted into negative charge. So carbon of acyl ion can easily attack at ortho position. And carbon number 1, which is bearing positive charge, will be neutralized when oxygen, which is directly attached with the phenyl ring, will donate its lone pair of electron to carbon number 1. So double bond is present between carbon and oxygen. Now, these intermediate loses HCl. Same question, how H plus and Cl minus comes? So Cl from AlCl3 and hydrogen from ortho carbon will combine together and it eliminates HCl, and it will be converted into ortho acyl phenoxy aluminum dichloride. And finally, when it is hydrolyzed, then it will be converted into ortho acyl phenol. In the same way, you can discuss the para attack. Next part of this rearrangement is very important part, that is the application of Fry's rearrangement. Now, first application is just given on your screen. According to this application, when orthochloro paratolulyl acetate and paratolulyl benzoate are reacted with each other in presence of anhydrous AlCl3, then two pairs of products are obtained. First pair of products are just given on your screen. These products are obtained when acetyl group of orthochloroparatolulyl acetase is shifted on its ortho position, while benzoyl group of paratolulyl benzoate is shifted to ortho position of its. This is the normal rearrangement products. While next is, in this reaction, second pair is the crossover products, in which acetyl group is shifted to ortho position of paratolulyl benzoate and benzoyl group will be shifted on ortho position of orthochloroparatolulyl acetate. So these two kinds of the products are obtained. Now, second application is the most important application of the Fry's rearrangement. By using the Fry's rearrangement, we can produce the adrenaline, which is used in the treatment of the heart disease. Reaction is just given on your screen. In this reaction, catechol, when reacted with the chloroacetyl chloride in presence of the pyridine base, then it would be converted into orthohydroxychlorinated phenyl ester. When this is reacted with the AlCl3 in presence of the CS2, then it would be converted into 3,4-dihydroxychlorinated acetophenone. When this is reacted with the primary amine, just take an example of methylamine, then it would be converted into secondary amine with the ketone group. And finally, when it is reduced in presence of the platinum, then it would be converted into adrenaline. This is one of the best application of these rearrangement. Now we are on a last segment of the rearrangement, that is the limitation. What are the limitations of the Fry's rearrangement? So first limitation is that if heavily substituted acyl components are used, then product will be less. Second limitation is that if meta-directing function groups are present on aromatic ring, then also the product will be less. And in third limitation, due to its harsh condition, only esters with stable acyl components can be used in the reaction. If we'll use the unstable acyl components, then reaction might not be occurred.